They say, oh my God, I see the way you shine. Take your
Hi,
hand,
I'm
I think,
Keisha.
and place them both in mine.
Hi, I'm Iza.
You know you stop me dead
Hi,
when
I'm
others
Aisha.
passing by.
Hi, I'm
Let me
Pinsri.
see you dance just one more time.
Okay, for the first subtopic, it is about calculating the volume of solids using general formula. For that, please look at the slide I've displayed at the front. Volumes of solid of revolution. Firstly, solid of revolution is a solid that is generated by revolving a plane region about a line that lies in the same plane as the region. The line is called an axis of revolution. To get a solid of revolution, we should start out with a function y equal fx on an interval a to b, just like the graphs shown below. How to find the volume of solid of revolution? The idea of finding volume is the same as finding the area. Slice the solid into pieces or slabs. Approximate the volume of each piece and then add them up together. Let us consider the solid as is the figure below. We first divide the solid S into n slabs with delta x, which is the thickness, and approximate each slab as cylinder. Volume is the ith slab. Area of circular cross-section times thickness, which is equals to Vi approximate A in the bracket xi times delta x. Approximation of the volume of S is given by V approximate summation I to n a times x to the power of I times thickness delta x. Okay, the first subtopic is disk method. Disk method is known as method of disk or ring to calculate the volume of solid of revolution by taking the sum of cross-sectional area that involves only one function. Okay, I'll show you all one example. First example. Okay, as we know that this example involves only one function, which is y equals to 1 over x, so we'll be using the disk method. The formula for disk method is v equals to integrate a to b pi times fx squared dx. Okay students, as we know in this question we have lines x equals to 1 and x equals to 2. So which is going to be the upper limit and lower limit?
X2 will be the upper limit.
X2, okay, the graph of y equals to 1 over x will be like this. And yeah, what is it?
X2 will be the upper limit.
X2 will be the upper limit and the lower limit will be
X equals to 1.
x equals to 1. So the region of the volume we're going to find is this region between x equals to 1 and x equals to 2. So, okay, to find the volume of this solid rotating about the x-axis, we'll use V equals to the formula just now. V equals to integrate a to b pi fx squared dx. In this case, we'll be using dx because we are rotating about the x-axis. If we rotate about the y-axis, we'll be using all the terms inside here as y in terms of y and dy. Okay, substituting the values of A, B, and fx, we'll get this, integrate this thing, equals to, expand the 1 over x squared. Integrate 1 to 2 pi 1 over x squared dx. Pi can be bring forward. X squared can be written as 1 over x squared written as x to the power of negative 2 dx. Integrating x to the power of negative 2 gets x to the power of negative 1 divide negative 1, 1 to 2. Okay, so pi negative 1 over x, limit 1 to 2. And we substitute the values of a and b, negative 1 over 2 minus negative 1 over 1, you get, what do you get?
1 over 2 plus 1. 1 over 2. Pi.
1 over 2 pi. Unit cube. Okay, for example 1, I have showed finding the volume of solid generated by rotating about the x-axis using disk method. So for example 2, there is a question in the whiteboard where the solid generated is rotating about the y-axis. So for now, I want you all to do it in a group. I give you all 5 minutes, discuss among your friends and solve the question. After 5 minutes, one person are required to come in front and solve the question. Your time starts now. Okay, your 5 minutes has ended. Can I have a volunteer to solve the question at the whiteboard?
Okay. For this question, firstly, we are going to sketch the graph. And since this is y square and plus 1, so it's going to be like this. 1. This is x equal to y squared plus 1. And the limit is from negative 1 to 1. 1 to 1. So this is going to be the rotating region to y-axis. Okay. From the volume of this method, it is going to be integrate from lower limit to upper limit of pi fy, since it rotating about y-axis, square dy. Okay. The lower limit is negative 1 up to 1 pi y square plus 1 square dy. Negative 1, 1 pi y 2y square plus 1 dy. I bring the pi since it has no y. Negative 1 y 4 plus 2y squared plus 1 dy. I'm going to integrate it, so it's going to be from negative 1 up to 1, and it's equal to volume for this question.
Okay, thank you.
Okay.
They say, oh my God, I see the way you shine. Take your hand, my dear, and place them both in mine. You know you stopped me dead while I was passing by. And now I beg to see you dance just one more time. Ooh, I see you every time. And oh my, I like your style. You make me wanna cry. And now I beg to see you dance just one more time. So they say, dance for me, dance for me, dance for me, oh. I never seen anybody do the things you do before.
The second subtopic to calculate the volume of solid generated is the washer method. Washer method uses the shape of washer to find the volume of a shape created by rotating two functions around x or y axis. It involves two functions while this involves only one function. Washer method involves two functions, which is outer radius and inner radius. The formula for washer method is V equals to integrate limit a to b pi f y squared minus gy squared dy. Fy squared, the first one, is the outer radius, while gy is the inner radius. Okay, for example 1, let's say you are given this graph. X equals to y and x equals to y squared, rotating about the y-axis with the limit 0 to 1. Okay, so for regions rotating about the y-axis, the outer radius is the top right, the most right, which is x equals to y, and the inner radius is the most left towards the y-axis, which is x equals to y squared. The formula for washer is V equals to integrate a to b pi the outer radius square minus the inner radius square dy. Substituting the value of a, b, inner radius and outer radius. A is 0, b is 1, pi. Our outer radius is in terms of y, so y squared minus inner radius is y squared. Y squared square dy. You can bring out the pi, solve inside. Y squared minus y to the power of 4 dy. Okay. Integrating y squared minus y to the power of 4, you'll get y3 over 3 minus y5 over 5. 1, 0. Substituting the value of 1 and 0, the limits, you get 1 to the power of 3 divided 3 minus
say, oh my God, I see the way you shine. Take your hand, my dear, and place them both in mine. You know you stopped me dead while I was passing by. And now I beg to see you dance just one more time. Ooh, I see you every time. And oh my, I like your style. You make me wanna try. And now I beg to see you dance just one more time. So they say, dance for me, dance for me, dance for me, oh. I never seen anybody do the things you do before. They say, move for me, move for me, move for me, eh. And when you're done, I'll make you do it all again.
Okay, the last subtopic for this topic is volume by cylindrical shell, which we call it as shell method. Okay, shell integration is a means of calculating the volume of a solid of revolution, also finding volume of solid of revolution when integrating along an axis perpendicular to the axis of revolution. This is the contrast to this integration, which integrates along the axis parallel to the axis of revolution. The formula in calculating the volume using the shell method is V equals to, also integrate limit a to b, 2 pi x fx dx. The x here defines radius, the fx defines height of the solid, and the dx defines the thickness. Okay, this formula can be used to find the volume of solid of revolution revolving about vertical line. Okay, to sum up our topics which we studied today, which is 3 subtopics from the topic volume of generating solid. The first subtopic was disc, second was washer, and the third one was shell method. And also not forgetting the very first one, which was the general volume, finding volume. Okay, so to see whether you all understand or not, so I've written here a question. So this is considered as your quiz. So please solve this. I didn't mention which subtopic this question is from. So you'll have to extract each information, see how many functions does this question provide, and the intervals, the limits, and everything. Please solve it according to what I've taught. I'll see whether you understood or not from today's lesson. Thank you. Okay, before we end our lesson today, I need one person to sum up whatever we studied today. So is there any volunteer?
Yeah, it's me.
Yes.
In summary, to find the general volume, we must use the formula of integrating area. For this method, we have to use the formula pi integrating fx squared dx, and for the washer method, we have to use pi integrating upper radius minus lower radius.
They say, oh my God, I see the way you shine. Take your hand, my dear, and place